Hi everyone, my name is Neha Kardam, and in this lecture we are going to cover the second part of encoding, decoding and 7-segment displays. So let's get started. So we're going to start with electronic encoder, and we are going to see how encoder converts from decimal to BCD, where BCD stands for binary coded decimal. So here in this picture you see a keypad over here from where we give the decimal input, and then that sends to the encoder, and the function of encoder is to convert from decimal to BCD, and the output is sent to the BCD. The BCD output is sent to the display. So this is our display where the BCD output is basically shown. So let's see. If we have 0, if we enter 0 on the keypad, then 0 decimal can be displayed here into BCD. And then if we press 5, then it will be 0101. And further, if we press 7, then we will have 0111. And then if we press 3, then we may have 0011. So you saw, like, as we were pressing the decimals, different decimals, then the encoder was converting the decimal into BCD, and that was displayed over here. And this screen could be any screen. It could be LED screen or LCD you can use. So these encoders, they comes in IC form, and we will be using encoders in our laboratory experiments, and you will also learn about how the truth table works for encoder in the next lecture. So far we know that encoder, they convert decimal to BCD, and at the output side we can use different types of displays. So now we are going to see some of the displays. So here we have 7-segment displays, and in 7-segment displays we have LED, LCD, and then we have vacuum fluorescent display. So these are the 3 different types of displays. So starting with LED display, which is a very common type of display, and it uses its power consumption is high. Its viewing is best under low light condition, and commonly you may see LED type display in red color, and however they are also available in other colors. An example would be wall clock in a digital clock, and some of the digital clocks, they have like LED display, and you may have seen in outside the stores also they have the hoarding of open and close, which has a LED display. And these can also be used in multimeter. In multimeters also sometimes they have LED displays. So this type of display is very common. And then we have a liquid crystal display. It is also called as LCD, and it is commonly have dark characters on a silvery background. It consumes less power, and its viewing is okay in good light, and its backlighted displays can be viewed in low light. And the examples are in modern days tools, for example cell phones, computers, tablets, desktop, and television. They have started using LCD displays. And so you know that the LED actually, so I'm going back to the previous one, the LED. You know that it generates light, whereas now this LCD simply controls available light. So this LCD has gained wide acceptance because of its low power consumption, and this LCD is also well suited for use in sunlight or in other brightly lit areas. Next we have a vacuum fluorescent display, and this type of display is a modern relative of the triode vacuum tube, and it has commonly blue-green display without filters, and it consumes medium power, and its viewing is good from dark to lighter condition, and based on vacuum tube triode, older technology it is made up of. And so this type of VFD is mainly used on consumer electronics equipments, for example in video cassette recorders. It can be used in car radios, microwave oven, these are used. So these are some of the examples where this can be used. Now next slide is the quiz, and the first question says the type of 7-segment display based on vacuum tube technology, which usually has blue-green characters and can be viewed in dark to lighter condition, is the vacuum fluorescent display. So is it true or false? So we just learned that in this type of display it uses mainly blue-green colors, and the viewing is better in lighter conditions. So this is true. And then second, we have the type of segment display that shows dark characters on a silvery background, uses very little power, and is good for viewing in bright light, is called the LCD. So is it true or false? So this is also true. And then last we have the 7-segment LED display is best viewed in very bright sunlight. So this is false, and you might have observed that too. Like in sunlight, the LED display viewing is not that good when compared to the darker condition. So this is false. So now next is the 7-segment LED display operation. So here you see the 7-segment LED display. If you count, these are the 7 segments, and starting from A, so this is your A, and B segment, C segment, D segment, E segment, F segment, and G segment. And then you have an anode here, which is at this side connected to the 5 volts supply, and then cathode is here, from A through G is your cathode terminal. And let's see, and then we have these resistor also. These resistors are the limiting resistors. So since this is your cathode terminal, then let's see what if we have some input, then what will be the output on the 7-segment display. So we have input here, high, low, low, and then rest of them are high. So so in this case, the B, this was your B and C, will be turned on, and rest of them will be off. So you see here B and C input active, therefore segment B and C light on display. Note that inputs are active low, and that's the reason why B and C are turned on. Okay, so if it was active high, then these two would be 0 or turned off, and rest of them would be turned on. So 7-segment display reads decimal 1 in this case when B and C are when they are turned on in this particular case of input. Now let's have a quiz. What will be the decimal output on the 7-segment display if we have this input? So you see here A, B, and C, these 3 are low and rest of them are high. So which means A, B, and C are going to be turned on, and rest of them are going to be off, because this is a active low input we are giving. So which makes it as A7. So 7 will be your answer. And then next is what is the decimal output on the display for the new set of inputs? So we have these inputs now, and this is active low again. So A will be turned on because this is low, and then it is high, and then C will be turned on, and then D will be turned on. So D will be turned on, and then this is low, and then F and G will be turned on. So so F and G will be turned on. So that will make it as a 5. So that's why we have 5 as answer. And then what is the decimal output? Again, we have different input given here. So all low, which means this is going to be all turned on, and that will make it as 8. And next we have these inputs. So it is low on B, C and low on F, G. So B, C and F, G, which will make it as 4. So that's why we have 4 here. Now next is decoder. So previously we just saw a 7-segment display, and now we are going to see how we can use the 7-segment display with the decoder. And decoder basically converts the binary coded decimal into a BCD into a decimal. So you see here a BCD input is basically sent from here into this decoder, and this is the decoder in the IC form. And then from this decoder the BCD number is basically converted into a decimal number. So here we have BCD input going into the decoder is 0, so that's why on the display you have 0. And let's see if it is changed to 1, 0 0 0 1, then your output is going to be 1 on the display. And if it is 1 0, then we know that this is 2 in decimal, so that's why you see here 2. And then we have 0 0 1 1, which is 3. So in decimal this is 3. And then we have 1 0 0, which is 4, and that's why you have here 4. So this electronic decoders, they come in IC and they translate BCD to decimal. Decimals are shown on an 7-segment LED display here. This IC also drives the 7-segment LED display. So this was your decoders, and in the next lecture we will see like how this decoder basically works. So let's do the quiz. If we have 0 0 1 1, then this is going to be 3. And if we have all zeros, then again it's the same 0. And if we have 1 0 0 1, then it's going to be 9. And if we have 0 1 1 1, then on the display we will have it as 7. And then if we have 0 1 1 0, then it's going to be 6. So answer is 6. So it was pretty easy. If you know the binary, how to convert binary to decimal, you can easily predict like what number is going to appear on the LED display. Now next we have a liquid crystal display. So these LCDs, they control available light, and they use a liquid crystal named a pneumatic fluid, which is sandwiched between the two glass plates. We are going to see the construction of the LCDs in the next coming slides. Third point says monochrome twisted pneumatic field effect LCDs display dark figures on a silvery background. LCDs are commonly used in watches, calculators, tablets, phones, in TVs, and color LCDs, they use either passive matrix or active matrix technology. So if you want to learn more, you can get in detail of this. You can research about this. This active matrix technology, this is most commonly used, and it is more expensive also. It uses a thin film transistor, and it has red, green, blue and white filters. So most laptops, tablets, cell phone screens are backlighted for brightness. So and that's possible because they use the LCDs. Now let's see the construction of the LCD. So this is a field effect LCD, which you see here. And when a segment is energized in this by low frequency square wave signal, then the LCD segment will appear basically black. while the rest of the surface remains shiny. So you can see here the segment, you can see this segment E. So you know that A, B, C, D, E. So this is your E segment is energized, and the non-energized segments, they are invisible. So this top layer is your polarizer, and then you have conductive pattern on glass, and then you have liquid crystal, which is pneumatic fluid, and then you have metallized layer, and then glass back plane, and then you have again a polarizer, and then you have these metallized segments, and then this is the contact. So in the LCD operation, the liquid crystal, which is this, you see here, which is made up of pneumatic fluid, is used, and it is sandwiched between these two glass plates, and then what will happen? The AC voltage is applied across the liquid crystal from the top metallized segment to the metallized back plane, you can see here. So due to the effect of the AC voltage field, the pneumatic fluid will transmit light differently, and then it will energize the segment, and energized segment will appear in as black on a silvery background. Now here this twisted pneumatic field effect LCDs, they uses polarizing filters on the top and at the bottom, and the back plane and segments are internally wired up to contacts on the edges of the LCDs. Only two of the many contacts have been shown here in this picture, and you can see here 100 Hz out of phase signal activates the segment. Now we have quiz. It says, while VF and LED displays emit light, LCDs either control available or sublimate red light. So in LCDs, we know it controls the available light, so this is going to be control available. And then pneumatic fluid sandwiched between the glass plate of the LCD is also called liquid crystal. So this is going to be the answer. And then monochrome twisted pneumatic field effect LCDs display dark or white figures on the silver background, so they display dark figures, so that's why we have dark here. And then liquid crystal displays are difficult to read under low light conditions. However, most laptop computer flat screens are backlighted to add brightness, so this is true. So now we are going to see the example of LCD display, and this is the LCD driver you see here connected, and then BCD input is going into this LCD driver. Is basically a decoder which will change the which will convert the BCD into decimal, and here display is our LCD display, and a clock pulse is given, 100 Hz clock pulse is given. So you see that you have 0 1 1 1. So ABC, you see the clock is turned on, so that's why you have A, B and C is on, and this is your 7. So the LCD segments with out of phase signals are active. So if you compare the waveform, the three waveform, ABC waveform with the rest of the segments, then you will see then when this is high, all these three are low, and when this is low, this is high. So this is out of phase with rest of the segments. And when this happens, then we have our LCD will be turned on, and we have 7 if this input is given. Now next is the quiz. So we have BCD input going into LCD driver, and then this is the LCD. So what is the output on the LCD display? So based on this, let's see. We see these two are same, and then this is out of phase going, and this is also out of phase, and rest of them are same. So if C and F are out of phase and rest are in same phase, so these are basically turned on, A, B, and then this D, E, and G will be turned on. So if that turns on, then that's going to be your 2. So answer is 2. Now in this case, when your input is this, so you see from A through F all are turned on, and then G is off. But there is some little mistake over here at the E. This should be same as that one, and if that's the case, then these all will be turned on, and if these turned on except G, then we will have 0. So answer is 0. And then in this case the answer is 5. A, C, D, F, and G is on, so that will makes up your 5. Now next is the vacuum fluorescent display. So in vacuum fluorescent display, we are going to quickly read the points. VF displays, they are used in automobiles because they operate at the proper voltages. They have pleasing colors, blue-green, easy to see when viewed under low light condition or when it is operating at wide extremes of temperature. And VF display, they are based on an older triode vacuum tube technology, and they are used in point of sale terminals and some desktop calculators. Now let's do a quickly quiz. A vacuum fluorescent display is based on an older vacuum tube technology and is commonly referred to as a VF display. So this is a VF display. And second is, one of the most common applications of VF display is in flat screen laptop, computer screens, automobiles. So automobiles, it has a common application. And then we have the VF display has the advantage of being easily readable in either light or dark conditions. So is it true or false? So it is true, because we learned that in different weather condition also the display looks fine. So this is true. Now we are going to see the construction of the vacuum fluorescent display. So the vacuum fluorescent display, it consists of 3 main parts of the triode tube, which are called plate, grid, and cathode. So this, you see the 7-segment display, this is your plate, and this is your grid, and then these horizontal, you see the wires, these are called your cathodes. So let's label them. This is your cathode, this is your grid, and these are the plates, and this is your glass back. So the cathode, these are also heaters, is basically made up of a fine tungsten wire, which is coated with a material such as barium oxide. So the cathode basically gives off the electrons when they are heated, and the grid is, you see here, is made up of stainless steel screen, and plate, you see here, this plate, they can be thought of as a collector of electrons in the triode tube. Now let's see the working of the vacuum fluorescent display. So first, what will happen, the cathode you see here of the cathode of the triode tube is heated, and some electrons goes into the vacuum surrounding the cathode, and then what will happen, the grid will become positive, and electrons will be attracted to the grid. And next, we assume that the plate here, this plate becomes positive, and when the plate becomes positive, electrons will be attracted through the screen like a grid to the plate. So electrons will be attracted to this plate from the grid. And finally, the plate is conducting electricity from cathode to anode. Okay, so that's how it works. Now, there are two ways to stop the conduction in the triode tube. First, you can make the grid slightly negative, and that will ripple in. If it is negative, then it will ripple the electrons, and they will not pass through the grid to the plate. And the second solution would be leave the grid positive, and drop the plate voltage, the voltage of here, plate voltage to 0 volts. The plate will not attract any electrons, and the triode tube does not conduct electricity from cathode. So in this, these are the two ways we can stop the conduction in the triode tube. Now quiz. Thin wires at A are called heaters. These are also called cathodes. A segment B are called your plates. So those are plates. And then the screen-like section C is your grid. Now next is the operation which we already discussed, that this is our cathode heaters. They heats up, and this is our grid, and this you see is basically your plates are. So these are your plates, and this is your grid, and this is your cathode heater. So when you give a supply to this, then they will heat up, and then they will pass the electrons to this grid, and from there to this, these plates are basically become conducted. So we see here for this 7-segment display, only these three are basically conducting. And that's why these are tied to 12 volts, and since grid is 12 volts, so that's why the same will display over here, and rest of these are at 0 volts. And if that's the case, then the display will be 7. So this is 7 decimal will be displayed. Now let's see the quiz. So this, what are these? We have to label all these. So A is the grid, and then B is the cathode or heater, and C is the plates. And then grid is normally at 12 volts. This is true. To light a plate, it must be grounded. No, this is not true. So this is false, because we want our plates to be at similar potential, if depending upon which one to be turned on. To light a plate, it must be at 12 volts. So yeah, this is true. So now this is the end of the lecture. Thank you so much for watching.